Well, hello. We're continuing our adventure on our unit Moving Straight Ahead, lesson 4.3. We're investigating today about parallel and perpendicular lines and how they show up in equations and on lines. So we're gonna first look at this group one. So I got 4 equations up here, and we're gonna graph them. I can already tell that they're linear because they each have like a coefficient. They have a rate next to them. So I know that when I graph these should be straight lines. So I want to keep an eye on precision. So a couple things I'm going to do is I'm going to make what I call like a T-chart. And it's called a T-chart because it looks like a T. So there's my letter T. And it's my way of graphing a table. It's making a table for each equation. So I'm going to go ahead and start this first one. A couple numbers I like to do first is 0. So if I plug in 0 for x, 3 times 0 is 0. So when x is 0, 3 times 0, then y will be 0. That's what's happening. I'm actually just working with the solutions of these things. So let's keep going. Now I'm going to try 1. So 3 times 1 is 3. So when x is 1, y is 3. I'm going to also do negative 1. When 3 is negative 1, okay, that's a little trickier. So 3 times negative 1, you know what? I'm going to stay in the positive numbers. Let's do that. We'll do negative numbers a whole nother day. That's another day. Let's do that another day. Let's try 3. 3 times 3 is 9. Okay, so when x is 3, y is 9. So that's ready to plot, but I'm going to wait and I'm going to do another T-chart. I'm going to build all my T-charts now. So x, y, or somebody might just call them a table. So let's do 0. So 3 times 0 is 0 plus 5 is 5. Okay, let's do 2. 3 times 2 is 6 plus 5 is 10. I'm going to do a negative number. We can handle it. Let's do negative numbers. 3 times negative 1 is negative 3. 5 plus negative 3 is 2. So when x is negative 1, y is 2. Yeah, we got this. No big deal. All right, let's do this one right here. And then, no, let's do opposite. Let's do this one. X, y. All right, when x is 0. So 3 times 0 is 0 plus 10 is 10. Let's do 1. 3 times 1 is 3 plus 10 is 13. How do I know what to put in for x? You know, I'm just picking numbers. Just picking any numbers. For these particular ones, I can pick anything I want. I am throwing a negative in there just to get me going on the negatives. Get that side going. 3 times negative 1 is negative 3. 10 plus negative 3 is 7. Now what I'm doing is I'm actually just doing 3 points because I know a line is 2 points. But 3 points let me know if it's going in the right direction. So if I can plot 3 and get it going, then my line should be okay. Let's try 0 for this one. 3 times 0 is 0. Negative 5 plus 0 is negative 5. Let's try 1. 3 times 1 is 3. Negative 5 plus 3 is negative 2. Let's try negative 1. 3 times negative 1 is negative 3. Negative 5 plus negative 3 is negative 8. All right, now I can plot. I'm gonna plot one of them with you, and let's just kind of see what happens. Let's plot this first one right here. So I'm gonna plot a point at 0, 0. I'm gonna plot a point at 1, 3. I'm gonna plot a point at 3, 9. And it should make a straight line. And it does. If you're using a ruler or something, and on paper, I want you to extend this to the edges of the graph so it fills the whole thing. There we go. I put arrows in the end. All right, will you plot the other 3 lines? Just get them all on there first. And yeah, so let's press pause and do the other 3 because I'm going to scroll to the next screen and I've done them all. So plot, plot, plot. Here they all are. This is how they all look. Notice what's interesting about them, okay? So the patterns we see is that these lines, a couple questions I'd ask you, will these lines ever cross each other? Will they ever meet anywhere? And they won't because these are parallel lines. So we can see that they are parallel by just looking at them, like these will never cross. But what makes them parallel? And if you look in the equations, what do you notice about the equations that are the same or different? And one thing you should recognize is that the rate is the same on every single one. They're positive and they're the same. And because they have the same slope, the exact same slope, they will never interact. They'll never bump into each other, never intersect. Now what's different is on the back end, the y-intercept right here, that is different on each one of them, and that's what shifts the line a little bit. So the slope is what keeps them the same slope, and that y-intercept is kind of as it shifts them all over the graph. Crazy, right? I know. Okay, let's do this group right here. Group 2. I'm going to do the same thing with t-charts. So let's build some t-charts. X, Y. Get some t-charts going. Let's start with this first one. When x is 0, y is actually 0. When x is 1, y is negative 2. When x is negative 1, y is 2. Do this one. Do another t-chart. Sorry if I'm going too fast. When x is 0, so 2 times 0 is 0, so 4 minus 0, it stays 4. When x is 1, so 2 times 1 is 1, 4 minus 2 is 2. Let's try negative 1. So, this one's an interesting one, because it's 4 minus, and then I've got 2 times negative 1, which is negative 2. 4 minus negative 2. It actually is going up in value, so that's going to be 6. So be careful of that one. Careful of the negatives. Let's do this one right here. I know I skipped one. I'll get to it. All right, so this guy, x is 0. So let's see. X is 0, y is negative 4. Careful of the negatives. When x is 1, so 2 times 1 is 2, so negative 4 minus 2 is going to be negative 6. Let's try negative 1. So 2 times negative 1, so that's negative 2. So negative 4 minus negative 2, it's actually going positive. So negative 4 plus 2, it's going to be negative 2. I know, it's still so weird how that happens, but you got to keep control of that. Keep an eye on that. Keep an eye on those negatives, especially when you're subtracting a negative. When x is 0, y is negative 4. When x is 1, y is negative 6. When x is negative 1, y is negative 2. Yay! All right, so we've got our t-charts. Let's do some graphing. I'll kind of do this first one with you right here. Now, we can already see in our graphs here, we can already see our y-intercepts. So we can see where these y-intercepts are happening. So just a little highlight there. Y-intercepts is when it crosses that 0. And plot this one right here. So 0, 0. I'm plotting this guy right here. 1, negative 2, negative 1, 2. So there is my line. And I am going to extend this thing. Come on, line. There we go, there we go. Yep, yep. Now what you're doing on your thing, if you're doing it on notability or if you're doing it on whatever you're doing it on, just bring it to the ends of the graph. That's like a technique you want to do. You don't want these tiny little solutions. You want them all there. Once you press pause and do the other ones, press pause and do the other ones. All right, look at them. Parallel, parallel lines. And you know what? Hopefully you kind of noticed it early. Is they're going to be parallel. They're, the slope and the unit rate is negative, which means it's going down. But notice that they're all the same. So these are going to be parallel. These are never going to cross each other. So something to recognize. Now the y-intercept, though, is what moves them. So they're getting shifted around, but they are all staying on the same slope. So if they have the same slope, they will be parallel. Yay! Well, thanks for doing parallel with me.